Hi, this is Mrs. Bustamante. We've been talking about photochemical smog. I want to continue talking about that today. And I want to look at this graph because this is a great graph to think about, one you might see on an FRQ where they ask you some questions about it and kind of draw some conclusions about why, say, ozone might be higher later in the afternoon when there's sunlight, or why we might see some of these peaks the way we do. So I think here's some questions I want to think about it. When are the NOx compound concentrations highest? Are they in the early, middle, late part of the day? Why do you think that is? When are ozone or oxidant concentrations highest, right? Ozone is an oxidant. And what is there any meaning to that, right? So I think something important for us to look at first, right? We'll make our graph a little bit bigger, is that down on our x-axis, it tells us the time of day. On our y-axis, it says pollution level in parts per million by volume. We don't actually have a title for this, but it's telling us something about air pollutants in a given city or given place, right, over the time of day. So when I look at this, the first thing I notice is that the graphs are peaking at different times. Different things are happening, right? But I notice my NOxes, my NO and my NO2 seem to peak first, right? And they start kind of low in the morning, and then maybe as the sun starts to come up, right, we start to see some peaks that occur with them. So why might this be? Well, early in the day, lots of people start driving, right, to work, maybe around these 8 a.m.-ish hours. And so that would make sense that you might see more of your NOxes early in the day with traffic. So how does that influence my O3 or my oxidants, right? Well, we know that O3 forms because when it combines, you kind of need your NOxes, right, and your VOCs. Those are precursors, right, we say, to O3 forming, and it gets produced with your sunlight plus oxygen plus these other things. So it would make sense, right, that when there wasn't much sun, it wouldn't really be in a peak, but as you got into later in the afternoon, maybe those oxidants, that O3 might peak after your hydrocarbons, after your NOxes peak, right? And then it would go down again as the sun, the heat kind of dissipated or went away. Notice that the hydrocarbons are earlier in the day, like the NOxes, probably again from auto emissions, right? And the aldehydes are a little bit later on, kind of like the other oxidants that we looked about there. So here's another graph, really similar, maybe a common graph you might see on an AP test, probably in an FRQ section. So let's walk through this graph, how we might solve it. Concentrations of various gases in air over a city on a typical smoggy day. So what do I know about this from the title? I'm looking at concentration of gases, how much there are. It tells me I'm in a city. That means I'm in some urban area, not a rural area. And smoggy tells me that there's probably some type of emissions happening. I look at my X and Y axis. I have time of day. It starts really early, probably before the sun is out, and kind of maybe early afternoon. And my y-axis is telling me parts per million, right? So I know a little bit about what it's showing me. And then I'm going to kind of think about, what do I see in this graph? Well, I see that there are different air pollutants there. I see that most of them start out pretty low, right, in the morning, and they have a peak somewhere in them, but they all peak at different times, and they peak at different rates. And they even all have slightly different concentrations in them. So what do my observations mean? Well, my observations that I just talked about probably tell me that there's some type of relationship between the concentration of gases and the air pollutants over a city on that smoggy day, right? So can I explain these patterns at all, right? Well, what do I know? I know that NOxes, right, tend to come from cars a lot. Maybe a lot of people are driving, right? So early in the morning, I don't really see them, but as people start to drive, yeah, I'm going to see them more. And again, with my hydrocarbons, right, a lot of those come from cars. But ozone seems to peak last, and aldehydes kind of along the same way, right? And we just talked about those NOxes, those VOCs. They're kind of like precursors. And we know that when they combine with heat and sun, they can form ozone. So that might be why this ozone starts to peak when it's sunny and after these have peaked, after they have been around for a while. That might be a question you see and some things that you should probably be able to interpret and take out of.